We're going to be talking about different types of information processing skills. We've already talked about this with adolescence. If you recall, with adolescence, we talked about five main changes that happen during adolescence that are measured from the perspective of information processing theorists, including things like memory and processing speed. We're going to be talking about those right now also with midlife. So as a whole, we see that processing speed is changing quite substantially as we get older. And processing speed is in fact even peaking typically for the average person in one's 20s and is declining shortly after that. If you've ever played video games or some other kind of like hand-eye coordination type of game with somebody who is substantially older with you, you may have found that they struggle with this. Maybe not horribly so, but maybe they weren't as good as they once were. Part of this is from practice. Like if a middle-aged individual has never played video games before, then their processing speed is probably affected in part by just not having that practice. But part of it is from just biological changes that are happening to the cognitive system. One of the ways that we measure this is through reaction time tasks. And so, for example, like just push button in response to a light, and they're measuring it in milliseconds. How long does it take that person to register that they saw the light and to press the button? Again, younger people are better at this. We also have more complex tasks. So like push your left hand, the left hand button when the red light and the right hand button for the blue light. So you see it gets more complicated. And as a whole, we just see that you get slower as you get older. Now, um, for some people this is pretty gradual and we don't see very big differences, but it still can have practical significance in our lives. I mean, just because the world is surrounded by things that we're processing and we have to act on it. Thinking about driving, if you're driving a car, you have to sometimes act really quickly if somebody is braking in front of you or if an animal runs in front of you in the road. These are issues of practical significance and having to do with processing speed. This is one of the biggest cognitive changes that's happening during this time period because it affects other cognitive areas. So if it takes you longer just to process information, this means that it's also taking you longer to work through and remember things. That's also a processing issue because you're trying to work up a memory from a long-term storage into our working memory. And so, or just paying attention to things. So processing speed is really important because of its change, but also that it affects other areas of cognitive functioning. And I'm going to explain on the next slide two views to explain why processing speed is declining. So why are there declines in processing speed? There are two main views to explain why, and some of this is theoretical, but some of this is also empirical. So it's not just like our ideas, but there is research to support these views. So the first view is called the neural network view, and this is the idea that just over time with normal aging processes, neurons die. And what happens is that there are breaks in these neural networks. So how the neurons are talking to one another. What happens accordingly is that the brain as it adapts and it forms new bypasses. So these are just new synaptic connections. But these bypasses are less efficient. It takes longer. So in my poor model here, you see on the left two neurons that are directly speaking to one another. And what's happening in that second group of neurons on the right is that, if let's say neuron B dies, well, there has to be a new path to get access to that information, whatever it may be, or to process information. And so instead of just being A goes to B, we have A goes to B, then B goes to C, then C goes to D. And this would take a lot longer. If you were trying to tell somebody that a party was canceled and you called them directly, that would be a lot faster than talking to friend A, and then friend A talks to friend B, and then friend B talks to friend C, right? And so, like, essentially, this is taking longer and this is resulting in changes in processing speed. The second view is called the information loss view. And essentially, the idea here is that as information is going through the cognitive system, so any part of the brain that has to do with just processing information, um, the system is slowing down to inspect and interpret the information, and that just takes longer. Essentially, what's happening here is equivalent to, if you take a picture of a book or a newspaper and you have this photocopy, there's already parts of it that are kind of fuzzy, like they weren't as crisp and clear as they once were. Now, if you take a photocopy of a photocopy, more and more of the information begins to be distorted. And in order to make sense of it, you have to really focus and pay attention. And, what was once was super clear is now grainy. So that's the same idea here, that the system is slowing down to inspecting and to interpret the information. And what happens as an outcome is that processing speed is declining. This isn't something that's a conscious process. This is something that is happening, unconsciously or subconsciously. But nevertheless, these are two mechanisms that are trying to explain why do we see these changes in processing speed just over time, starting in one's 20s, but particularly in one's midlife. Next, I want to talk about memory. As a whole, middle-aged and older adults remember less than younger adults. That's just a common finding. But it also depends on what type of memory we're talking about. So for middle-aged and older adults, we already talked about how verbal memory was something that's peaking during this time period. So it's not all types of memory. They're not all equally the same. Spatial memory is something that is not as good. So before I was talking about spatial orientation. So that's understanding how objects exist in space, whereas spatial memory is where remembering where things are. And I don't just necessarily mean like, oh, I can't remember where I put my keys or where I put my cell phone, although those do apply. But this is kind of related to your ability to remember where the store is located in comparison to your house. So being able to draw a mental map, or a physical map of your neighborhood or your town. So these are some of the changes that are happening, but as a whole, again, there are some individual differences, and we'll talk about why some of these memory changes are happening on the next slide. First, I want to mention, on the last slide, I was talking about how memory declines and the types of memory that are changing. Remember, this is midlife. When we get into old age, we're also going to talk about issues related to dementia and Alzheimer's, so illnesses that play a role. But at this point, we're not talking about that. This is just normal memory changes that occur over the lifespan. So, what does the research say for why memory declines? One of the reasons why is that we have a decline in our strategy usage. And so at any point in the lifespan, if we're trying to remember something, we may engage in any number of different strategies to remember that. So it could be, for example, rehearsal. So repeating things over and over and over again until it is put into memory. Maybe we're making connections with things that matter to us. So making these associations that help us remember. One of the findings shows that older individuals tend to rehearse less. So if they're trying to remember something, saying it over and over again in their head. And this may be because of a slower rate of thinking, so it's harder to repeat it over and over again, maybe due to processing speed. They also have a reduction in working memory capacity. So this is our ability to actively work through problems. And so if we're not actively working through problems and trying to make sense of them or thinking about them in the moment, then one, working memory is affected, but also potentially the ability of that information to make it to long-term memory. As we already talked about with even processing speed, that it's harder to recall memories from long-term memory, so that LTM is long-term memory, and that's partly because there's more irrelevant information in the way. Going back to the processing speed, argument that we're not just going from neuron to neuron, we're now going from neuron to neuron to neuron to neuron to neuron. There's a lot of more there's more information that can get in the way, that's cluttered. On top of that, you just have had more life experiences, which could affect some of that irrelevant material. For working memory, there's also, it's not just a strategy, but it's harder to tune out irrelevant information. So it's not just the fact that the irrelevant information is there, but the fact is that it's harder to just shut it out of the way. Like it's affecting your retrieval. And we'll talk more about attention in just a second to show how that is related. These are just some of the mechanisms, by the way. This is not an exhaustive list.